Right. I've set myself a relatively ambitious title, Establishing a Language of Trust, with a smorgasbord of buzzword bingo words at the end of it. But essentially what I'm going to try and do in the next sort of like 15, 20 minutes is try and pull together a few different tendrils of some discussion that's happened already this morning and will go on this afternoon, and try and give you some sort of map of how all this stuff practically fits together. So John talked about zero trust earlier on. So yeah, it's a great idea. I mean, what is zero trust all about? It's basically about saying don't assume too much, right? Test, validate, continuously assure. But the problem is when you fully embrace that, it leaves you with a bit of a challenge. So where do you build the trust up from? How do you establish those hooks on which you're going to make those decisions if you can't use the implied trust? So this is this somewhat, grandiose ambition I've set myself, trying to sort of like describe to you a language of trust, and it is somewhat grandiose. It's in its broadest form, you can see it as a unified language of security, which is obviously stupid and ridiculous, and I'll never achieve that. But there's a very, very practical element to this, which is in reality, in a zero trust environment, you're having to make these decisions. You're having to make a decision on how much do I trust this specific IoT device on the network and what do I use to do it. And that's what I'm going to try and talk through in the next couple of slides. And in terms of the agenda, I think I've quite neatly positioned between Ian, who's just talked to you about compliance frameworks, how you might evidence certification, how you might evidence compliance with legislation, which is one side of things, and Paul, who I don't think is here, but we've got the pleasure of having Michael talk in a minute about some of the NIST work on trusted onboarding. And what I'm going to talk about sort of blends those two things together, because it's going to talk about how do we take evidence of trustworthiness, and then use it in a real-world operational scenario, and as Michael will give more details on later on, under what circumstances should you allow a device to, in a trustworthy sense, enter a network. There's also some tendrils that hook into some later parts of the agenda to do with the memory security discussions. So when you look at the problem from the network side of things, you haven't really got much to go on. I mean, we've been looking at this problem for quite a while. If you are a router, if you're a network, and you're trying to establish the trustworthiness of end devices, what can you work on reliably? I mean, what do most sort of cybersecurity systems use? Well, you've got your IP address and you've got your MAC address. But the truth is they're both eminently spoofable, very volatile, and not really a reliable thing on which to make long-term trustworthy assessments. Now, the behavioral data you see coming off those devices possibly is a little bit more reliable because it's harder to spoof, because literally that's the traffic going through. But you still need to anchor it on somewhere. And this issue of sort of like anchoring and identities, which Darren mentioned earlier on, I'll come back to shortly. And so the other big picture thing I wanted to discuss was the full IoT life cycle. So I think similar versions of this slide have already come up in the keynote and subsequent ones. And it's really reinforcing one essential point, which is the trust problem, the security problem, is a full life cycle issue. And there's at least sort of like four things to draw attention to here. So one, as the NIST keynotes said earlier, the attack surface is the full life cycle. Right? It's not trustworthy unless you can be sure of each and every single element from the design through to the retirement of that device. But in the same way that the attack surface is a full life cycle, the defense surface, if that's a word, is also full life cycle. So the things that you can do higher up, earlier on in the process, affect how trustworthy, how attackable the device is downstream. But in order for you to use that, you need to be able to propagate that information. So we can use like secured by design as an example. I mean, let's take an extreme form of secured by design, which might be a cherry-based architecture. It's great that you've built a system using these memory vulnerable principles, but unless the downstream processors are aware of it, that information is lost and you cannot change your risk metrics downstream. The third thing I want to mention about the life cycle is the way we approach it is just accept the fact, again, I think this point was mentioned in the earlier keynotes, that the supply chain of that life cycle is increasingly distributed. There aren't single control points. So the method by which you propagate this information must embrace sort of trusted, distributed methods. And then the final piece is, in my opinion, is I think there are some key pinch points in this life cycle that are really the main places where you can exert control. Procurement is a key one, and we'll come back to this later. Being able to make selective decisions at procurement can fundamentally affect how trustworthy a device is. Onboarding, and this is really the subject of the NIST IoT onboarding work. You know, if you can calibrate that onboarding process to evaluate trustworthiness, that's another major control point. And the final one is retirement. I know Darren said earlier he never sees any devices retired, but to be honest, unless you chuck the rubbish away, at some point you've got a bit of a problem. So those are the sort of like key facets of the life cycle that I think are somewhat under represented in the current way of looking at things. So, building trust. Where do we start? Well, I've already said IP and MAC addresses aren't great, so what do we use? Well, device identities, strong certificates are obviously a very, very good contender. Now, they come in lots of different flavors. In the NIST work, we've looked at a lot of IDEV IDs, which is essentially an IEEE standard, but I think other things like Matter use subtly different variations of device identity. But the key point about the device identity is it's really asking one very important question. Is this device the same as the device that I've seen before? That's the first and most important question you need to ask. Everything above that's gravy, but that in and of itself is a hard question to answer reliably. And you really need some sort of certificate type technology to do it properly, because you need a key, a hidden key that's not going to be sort of like made visible. But once you've got that, then you've got optional signatories which give you a sense of provenance and extra attributes you can add on. But this issue of device identity is pretty critical, because whether it's real, i.e. you pulled it from a certificate, or inferred, everything else daisy chains off this. So the next key element was who made you? Where did you come from? What's your parentage? So in a lot of enterprise systems or even consumer-based systems, you might well have a list of approved suppliers. But the question is, well, how can I be really sure you really are that device? And then even if we're going to use this as a test, and it is, and in the NIST work you'll see that there are very strong methods and protocols for being able to investigate this. Even if you have a method for doing it, then you've got to ask yourself some other question. Well, are you still in business? Because the reason I'm asking who I'm made by is probably because I'm expecting updates from you. And then there's the other question, well, do I still trust you? I might have trusted you before. I might not trusted you, further down the line. The Huawei example is a great example. Before a certain date, it was a trusted piece of telecoms infrastructure. After a certain date, it wasn't. It's a dynamic construct, and the systems need to be able to reflect that dynamism in a reliable way. So then what are you? What is your function? So obviously, a light bulb and a camera are quite different. And that's very, very different, as Peter was saying in the panel earlier, the thermostat on energy plants. They're all IoT devices, but what they are, the function that they are delivering, is critical to being able to evaluate their trustworthiness. And that gets into, and this concept of model number or SKU actually is very, very important for being able to unwrap the security credentials of the device. So we need a way of doing this, of understanding, well, I know this is from sort of like, Cisco or BT or whatever, but what is the specific bomb, the specific physical device I'm talking to? Because from that, then I can infer its purpose. Then what version are you? So what's the difference here? Well, this is software. So the PSTI regulations say you've got to keep things, updated. You've got to make sure you can update the software. So, can you take updates? Well, we'd hope yes, because that's good security practice. So which version are you now? As far as I know, there's no real strong interoperable method of being able to investigate that reliably, remotely. But, if you can't do it directly, you need to be able to do it indirectly. And And how does that impact anything you might have already told me if I've changed? And do you need an update? And then this is a key one, and I think this is, to my mind, one of the sort of like most interesting aspects of the NIST onboarding work is the notion of ownership, device ownership. Device ownership is obviously critical. Essentially, when I buy a device and bring it home from John Lewis and try and attach it to my internal network, essentially, in a very obscure and quite painful way, I'm establishing the fact that I own this device. And if the way I'm doing it is embedding the password in there, that's the worst way of doing it, but there are better, higher order methods of doing it. But when it comes to enterprise, this sort of becomes essential, because if you want to deploy 10,000 devices at scale without touching it, you need a way of asserting ownership of device, and in an ideal sense, be able to use that evidence of ownership at the point of onboarding. It makes the process more secure. It also makes it more usable. And then there's there's a whole can of worms, to be honest, once you start digging into this. But there needs to be a method of asserting ownership. But can I just grab ownership? Do I need the other person's permission before I can take ownership? Things like Matter and FIDO have got some quite strong ways of doing this. There's sort of other IoT specs have got slightly weaker ways of doing it. But the one thing that I'm really keen, I keep repeating now, is the concept of mobile networks. They've got a really awful way of asserting device ownership. My phone in my pocket has got my Vodafone SIM in it. If I take the SIM out and put it in John's phone, to all intents and purposes, John is me. Considering this is one of the oldest sort of like networks around, it's got one of the weakest forms of ownership identity there is. And if you sort of dig into the detail, that weakness is actually responsible for some quite major bank frauds at the moment. And the irony I find, if I go down on the tube and get on my Vodafone Wi-Fi, Vodafone's got a much stronger concept of who I am as the owner than when I've got the SIM in its native mobile network, because I'm entering my username and password. So this concept of ownership is really quite critical for increasing the language of trust on the devices. What are you supposed to do? This is the basic concept of least privilege or intent. If I've got a webcam, what addresses should it talk to? What port number should it talk to? How frequently should it talk to? If I'm able to assert this as the manufacturer, then downstream entities are able to enforce that or police it and make sure I'm not going outside of the envelope that I've declared for myself. So we'll talk a bit about where this actually sort of like is standardized, but there's things like MUD, manufacturer usage description out of the ITF, that do this very, very concretely and specifically. And then obviously the other side of that is once somebody's made a least privileged assertion of what I think the device should do, well, what do you really do? Now, I know this if I'm on the router because I can see this. And it's a simple check then to reconcile the intent with my actual behavior. If I've got that working, I've got a really strong system. And then you can do even fancier stuff. You can start doing all the AI fancy, induced behavioral footprints and that type of thing. But you need the mechanics, the individual elements to be able to build this up. And here's where we get into Ian's stuff. And I think if we only really do one thing and bridge one thing, it should be this thing, right? Which is, I've got an IoT device. It wants to connect to a network. Supposedly at the moment, IoT devices in the UK should comply with PSDI. How do I know that? It should be a solvable problem. If I can go from device to device type to firmware to look at whether there's a statements of conformance against that, that is how we operationalize a lot of the value that IoTSF and other organizations have created. And I think therein also lies some of the long-term value of the assurance framework, because it's not only a good set of just basic security requirements, it cross-maps it to different regulations for different countries, or it could cross-reference it to different procurement requirements. Then, more nuanced that, have you been tested as an individual? There's a difference between testing the type and testing the instance, but this is another sort of like common thing, another piece of health. And then the final piece of the bit I want to describe there is what software are you running? So this is the SBOM question. So where does the SBOM come from? It basically fundamentally daisy chains from the device identity, as I'll show you in a minute. But once I know that, I can do useful stuff. I can check whether I conform with my commercial licenses, my export licenses. But the real value is then digging into the vulnerability analysis, because once I know what components are in there, I've got a strong dynamic sense of what the risk is if I've got an idea of what the vulnerabilities are out there in the big wide world. How much have I got? Oh, right, okay. Better speed up then. So, right, imagine if I can't read this. So this is the nice story. What if the network knew when I was made? It knew that I was a security webcam. I was made from Webcams R Us or whatever the manufacturer is. It knows my model number. It knows the version number. And if I know the model number and the version number, I should be able to check if I'm compliant with PSTI and or any other regulation that is possible. If I give my SBOM, I can see if any vulnerabilities, known vulnerabilities are known now or in the future, because I can just literally look it up. I can see if I've got a particular component there. I can see if I'm built with Cherry, which should make me resilient to a whole load of these sort of like vulnerabilities. I can see, well, what does this device normally do? And what am I doing now? Is there a difference? Who have I been installed or configured by? Is it a trusted person? Who am I owned by? If I'm on an enterprise network, I expect to be owned by the same person who owns the network, or those organizations should have a relationship. And then you can get into the much more dynamic stuff in terms of looking up CVE. So as you can see, this is quite a nice story. I think it's a nice story. It's not just a nice story. I sort of think it's sort of common sense. But the nice thing is, as hopefully might become better, it is real. I think or a good chunk of bits of it are. Everything that I've just described maps onto a formal piece of information which you can describe a concrete relationship with each other. We've got full schemas for doing this. There's a few weak points. It's not totally perfect. And we've got a language for doing it, which is these sort of like W3C verifiable credentials. Basically, it's certificates on steroids, but they have the same essential properties that I've got a piece of evidence that I can reason on from a trustworthy source. And it works, right? So a good chunk of everything that I've just described is live on the NIST servers in Washington as part of the Build 5 that we've built in collaboration with others. And this reference architecture diagram, I think there's two things I want to draw attention to. One, that continuous assurance box there, that's us, right? That's the collective IoTSF community. We inserted that in there because that resonates with what we believe are requirements long-term for IoT security. And two, this piece, I think, is the most important part of the NIST architecture. There is a relationship between supply chain evidence and manufacturers and the network onboarding component. If you take nothing away from this conversation, try and understand this, because I think this is transformative. What it's allowing you to do is it's allowing you to use procurement information at the point of network onboarding. And I think this is a major shift in how we can actually usefully implement and police trustworthy IT onboarding. So that's the main themes that I wanted to get across with regard to taking a bit of a sort of like long journey of how we tie all of these different pieces of information together in one framework about which we can reason. And I think we've already evidenced the fact, there's a little bit more to do, but I think we've evidenced the fact this works in an operational setting and delivers major security benefits. If you want to get really advanced, you can start looking at the AI stuff. And I think this is quite interesting. And if you can come and have a look at some of our demos we've got upstairs. But I think it's still emergent, but a lot of the primitive technologies and components that I've just described in terms of how we build up these trust relationships for IoT devices across the full life cycle transfer almost exactly into AI. It's a harder problem, a much harder problem, but a lot of the building blocks can be used in a similar way. And yeah, that's just an AI lifecycle picture. Those are my contact details if anyone's asking questions. Yeah, thank you very much.